Neocloud operators don't sell storage, you sell queries per second within SLA. But as context lengths grow, kvcache spills out of GPU memory. When the attention kernel hits a missing kv block, the GPU stalls waiting for data to load. Those stalls cascade into head-of-line blocking. Throughput drops, latency spikes, and your SLA breaks. The naive solution is to prefetch everything, but that scales linearly with context size and overwhelms the network. What you need is a system that can predict and fetch only the kv blocks that matter, before the GPU needs them. LightInferra by Lightbits is a purpose-built data platform that scales AI inference beyond the limits of physical HBM and DRAM. By providing an ultra-low latency proactive kvcache, we eliminate the memory wall for long-context LLM inference deployments. This enables near-unlimited context, accelerated time-to-first token, and a practical path for persistent agent memory. In long context benchmarks, LightInferra reduces time to first token from seconds to milliseconds, delivering up to 286 times improvement on the critical path. LightInferra solves the long context problem by combining sublinear attention prefetch with a distributed memory fabric. Instead of scanning an entire attention window, LightInferra runs a sublinear sparse attention prefetch engine, or SLSAP. It identifies the kv blocks most likely to be used next using locality-sensitive hashing and statistical reuse patterns. From thousands of possible kv blocks, the system selects a small working set, top M, where M is far smaller than the total context. That means prefetch work grows with sparsity, not context length. Once selected, kv blocks are fetched through the Light Cortex fabric, a distributed memory layer optimized for GPU inference. The fabric routes requests directly to the correct storage device in constant time and moves kv blocks over RDMA into the GPU memory hierarchy. And because real inference workloads run many agents simultaneously, LightInferra schedules memory traffic by agent priority. Latency-sensitive agents always move first, while background workloads consume remaining capacity. The result is simple. The GPU rarely waits for kv data. Here's the comparison. The baseline, turn 1, is the initial prompt ingestion, where the model processes the full input and builds the kvcache from scratch. The system hits kv page faults and stalls the GPU. Turn 2, cache reuse, measures the time to first token when the user returns to the same conversation. Instead of recomputing, the previously generated kvcache is retrieved and reused. With LightInferra, the required kv blocks arrive before the attention kernel needs them, keeping throughput stable even as context grows. LightInferra delivers up to 286 times faster response times and 3 times higher performance than alternative approaches we tested. By fetching kv blocks sublinearly and scheduling memory by agent priority, the platform keeps GPUs generating tokens instead of waiting on data. But the real impact is on your bottom line. In a 10,000 GPU fleet, a 30% efficiency gain reclaims $111 million in capex and delivers 30% more inference per watt. LightInferra ensures your AI factory generates tokens, not heat and idle power. Every stalled GPU is lost revenue. Stop waiting on data and start reclaiming your margins. Come see the LightInferra demo at GTC or click the link in the description below to learn more.